Oh, good morning, everyone. So I hope all of you can hear me and see my slides. Wonderful. Okay, I guess let's get started. Welcome to this little webinar about AI agents and how they also need a good development platform. Regarding myself, I'm Florian Assmus. I'm the CTO at PRODYNA. I've been with the company already like more than 18 years now. Been doing software development for over 25 years in a professional context. And I'm very passionate about cloud native technologies, platform engineering, and nowadays also everything around AI. So I'm really happy to talk to you about two of my favorite topics. One would be platform engineering, the other is agentic AI, that really shine together, I think. And this is what I want to bring across this in course of this webinar. So first I will start a very brief introduction of platform engineering. It's not Kubernetes, just a little teaser. So I will quickly explain what I understand from platform engineering, and then we will have a look how agentic AI that's popping up everywhere impacts the whole discipline of platform engineering. So let's dive right in. What have we seen the last maybe 10 years? We try to shift everything left. We want to fail very fast. We want to move very fast, and best case, the developer or the dev team can do everything themselves. So they have all the tools available. They have the best and scalable infrastructure. They can do self-service for everything. Sure, when you have self-service, you want to automate everything. Let's also shift security to the left, to the development team, and work. Why not also put the operations in the development team? So everything together, end to end, they can deliver an application. And what we hope to achieve is a high degree of autonomy for these development teams, agility, so they can decide when they want to do what, very fast time to market, scalability, improved security. There is so much that we hope to gain, but the reality showed that all of this requires tons of knowledge that the usual developer doesn't have, or the team itself does not have. And this massively increases cognitive load on the teams, and they start focusing more and more on solving infrastructure problems instead of actual business problems. So to some degree, they get faster, but at some point, especially in a larger organization, this becomes very inefficient, because every team needs to solve all the problems of the world themselves, and for every problem a new solution pops up. And this is exactly what platform engineering tries to address. So somehow moving away from the every team for itself to let's build a centralized platform that supports our teams. And I really like this definition from Martin Fowler and Ian Botcher. A digital platform is a foundation of self-service APIs, tools, services, knowledge, and support around this, which are arranged as a compelling internal product. And then autonomous delivery teams can make use of this platform to deliver product features at a high pace with reduced coordination. And this is really what an internal developer platform is about. And now you can see that this is more than just infrastructure. And what are the properties of such a platform? Number one, the platform itself is perceived as an internal product with the development teams as the users. And this is now where the big change happens with Agentic AI. We now not only have humans as the users of the development platform, we now also have AI agents that want to help in the development process. So they are also now becoming users of our internal product. And one key for platform engineering is to take the user into the center and figure out what the user needs, understand how the user uses the platform, what the experience is. And this is now also very, very crucial when we talk about agentic AI. Moreover, a platform should be documented. It should be easy to get started. And next one, self-service. Oops, sorry for that. Self-service is very important to keep the agility and speed for the development team. So we don't want a platform where you have to request every feature, every tool you want to use using a ticket, but now you should be able to use it when you need it. So self-service. And it should reduce complexity for our users, so they not have to solve all the nitty-gritties, but it's already, everything is prepared, everything is ready for the user to consume. It should be optional and composable, so we don't want to force on anything on the development teams. They should pick and choose which kind of functionality or capabilities of the platform they actually want to consume. And if they consume the capabilities, they should be secured by default. A very, very nice white paper I can only highly recommend. I will put the link quickly to the chat. 1 second. Where's the chat? Here we go, everyone. So I put the link to the chat. It's a white paper from the Cloud Native Computing Foundation, really distilling down what platform engineering is into a nice white paper. And this picture is derived from there. So we have the delivery teams on top with the platform interface that is compiled out of documentation, a search so that you can find everything that you are looking for, golden path templates or project templates, infrastructure templates that the projects can simply use and that are proven, APIs, CLIs for automatically consuming capabilities of the platform, and in many cases also a graphical user interface, which is the developer portal or something like this. And underneath this platform interface, we have different capabilities. So these are features or capabilities that developers need to deliver their applications. And all of these capabilities are, at the end of the day, backed by some providers, or some even could have more than one provider. So you could have, for the infrastructure part, you probably have some one or two cloud providers or an on-prem data center. So this is basically abstracted away. We are looking at capabilities, and then we will figure out how we can provide them. So this is platform engineering in a nutshell. How does this now relate to AI? Let's get back to this picture and think about one major change that agentic AI has on this. And what actually happens is that our delivery teams now are extended with agents. So I'm not only talking about having a co-pilot or a coding assistant in my IDE. I'm really talking about AI agents that work asynchronously, so that where you can assign tickets to them. They can start working on these tickets, deliver results. Probably we will have more than only one agent. You probably have specialized agent for different tasks, closely collaborating with the humans in the team. So this is really a major shift. And to enable these AI agents, they somehow need to get access to the platform. We already thought about an interface for our developer platform, developer experience. So how do our developers consume this? Now we have to think about, okay, how do our agents consume our platform? And they have different needs. So yes, they can use documentation. Yes, they can use APIs to up to some point, but these interfaces, they are not optimized for being consumed by an AI agent. So we will probably need something more sophisticated here. And when we start providing interfaces for agents, this will probably impact all our capabilities in the platform. So we will have to look at every single capability and figure out how we can make this accessible to our AI agents. Luckily, as you will see very soon, standards are emerging, so we don't have to invent something ourselves. And once the agents get access to the actual developer platform, they can start collaborating with humans, in many cases using the same mechanisms that humans use for collaboration, by creating pull requests, commenting, reviewing code, putting the commands into our Git platform, for example. All of this, the AI agents, once they have access to the platform, they can also participate in this communication and collaboration, or get access to your chat or channel and start posting messages, or really starting collaborating in your chat system. Another aspect that we will probably see as a second step is the AI agents also need to start collaborating amongst each other. So we will have specialized agents for different tasks, and they somehow need to collaborate with each other. So we need to know what each agent can do, and they need to be discoverable, and then they need to start collaborating with each other in a secure way. The time to this is not part of the webinar today. We will mainly focus on the agent to platform communication. Another important aspect is that we need to rework or revise our existing templates. So our project and environment templates, code examples, blueprints, whatever, they were built for humans. And for agents to actually work on the code base, we need to enable them specially. And so you really have to look at many different parts of your developer platform and see how you can optimize it for the use of AI agents, for AI agents. And the two topics we will be focusing on is agent to platform and project and environment templates, how we can improve them. And you probably have guessed it, when we talk about how the agent can talk to the platform, there is one standard emerging, which is the model context protocol. So like half a year ago or a bit more, every big AI player started to build their own extension model. OpenAI did, GitHub with their Copilot, you had Copilot extensions, but these were all proprietary, and you always had to figure out, okay, how can I integrate my tools and my environment into my AI agent? And Anthropic, I think a model context protocol was initially proposed by Anthropic, but it's open source, and the larger AI community found it extremely helpful and started to adopt it. So Microsoft adopted it, AWS adopted it, GitHub adopted it. All the coding clients that you're currently seeing out there, Claude and Cursor and so on. So they are all now converging to MCP for a way to integrate external tools. And how does MCP actually work? We will really have a look into what MCP does, because it's not particularly complex, but it's purpose-built and designed for AI. That's the important thing here. So you have three components or three participants, which is the MCP host. That could be your AI application, your VS Code, for example, is an MCP host, or your custom agent that is running somewhere. And this MCP host can open client connections, or can create MCP clients that connect to an MCP server. And the important part here is really that it's a one-to-one connection. It's stateful, so they can be directional, call each other once the connection has been established. And yeah, so this is a quite important aspect here. And the whole protocol is divided into two layers. The layer number one is the transport layer, which is basically there are two options available. One is standard I/O. This only works on your machine. And the other option would be a streamable HTTP transport layer. So these are usually then called remote MCP servers that you can call over the network. And then the second layer, that's the important one, is the data layer. The data layer is independent from the transport, so the messages and everything that are exchanged are always the same, but only the way of how the communication is handled underneath depends on the transport layer. And the data layer really is how client and server exchange messages. And this is done based on the JSON RPC 2.0 protocol. In a nutshell, JSON messages are exchanged, and MCP defines the message format and the semantics of the messages. So that's the core of the MCP protocol, the messages and the semantics behind the messages. The messages are divided into 4 categories. Number one is the lifecycle management. So this is actually for establishing the connection. And then we have server features. So this is functionality that the server offers. We have client features. What functionality does the client offer? And we have some utility functions. So for example, notifications can be sent from the client to the server and from the server to the client. Both directions work. And we will quickly go through these different areas of the protocol and see what's actually behind it. So the lifecycle management is this is how everything starts. So when a client wants to connect to a server, it sends a initialization request. There is some version negotiations happening. The client tells the server what kind of capabilities it has. So we will see these capabilities in a bit more detail. So the client has 3 capabilities: routes, sampling, and elicitation. We will get to that. And then the server can respond and tell the client, yep, okay, here, that's my version. And I have following capabilities. And the server capabilities are prompts, resources, and tools. So these are the primitives, basically. Once the negotiation, the initialization phase is done, the actual communication can happen. They can send messages back and forth. And at the end of the day, when I shut down my client, there's a little termination sequence for gracefully closing down the connection. So this is the initialization or the lifecycle management. It's very important because we are dealing with a one-to-one connection, client, server, and they can bidirectional communicate with each other. So what are the server features that are supported by MCP? Number one are so-called prompts. These are predefined templates that the client can call. It's pretty straightforward. So how does it look like? Actually, on a protocol level, the MCP client, it's important to understand the direction here. The client can call this defined method because the server said, yep, I have the capability of prompts. And the client can say, hey, provide me a list of all your prompts. And the server responds with a list of prompts it supports. And every prompt has a name, a title, a description, and a structured way of defining the arguments that the prompt expects. This can be a long list, and then the client can decide, oh, I want to call the code review prompt. And basically, you do also a method call. This time, you do a get with the name of the prompt you want to call, and you put in your data, and the client will respond with the result of the prompt. So it will receive it, hand it over to the LLM, do everything that it needs to do, and hand back the result. Straightforward. The next one is resources. So the server can offer resources to the client. This is a way of providing structured data or content to the client. And in that case, the client can, if the server tells the client, hey, I have the capability of providing resources, the client can call the method, hey, resources list, and it will get back a list of all the files, what kind of MIME type they are, the name, title, description. There's a lot of human readable text in there. That's very convenient when you work with LLMs for the user in the loop. You always have nice descriptions and yeah. So once you have the list of files, the client can say, hey, I want to get this file based on the URI, and the content will be delivered. Yeah, also pretty straightforward. The last but not least, the MCP server can offer tools. So these are executable functions that allow the model to perform actions or retrieve information. And this can be pretty much anything. Same pattern here. I want to list all the tools available. In this case, we have the get weather tool, and it tells us, hey, when you want to call this tool, please hand in the location as a string. So we always have JSON. We have types in there, so the MCP client exactly knows what to hand in. And yeah, once we call it, the MCP server can call whatever API tool or whatever it is, or just the library, produce some output and provide it back to the client. Now we are turning around the communication. So these are the client features. And the first client feature is the client can provide information about the file system to the server. So basically, where's my root of my project? what files do I have open, and all that stuff. So it allows the server to understand directories and files that you on your machine have access to. In that case, the message is sent from the server to the client, asking the client, hey, provide me a list of your routes. And this is the response. So it's pretty straightforward. The next one is sampling. So the client can offer the capability sampling or the feature sampling. And in that case, the server can use the LLM from the client to do some completions or generations. This is very helpful if the MCP server itself has no API key for an LLM or whatever. It can ask the client, hey, I have a message for you. What is the capital of France? Can you please answer that? I would like to do it with a Claude 3, so you can give a model hint, some tweaking of the model, a system prompt, and the MCP client can use its own LLM to respond to this answer. And something similar in that case, the elicitation, the server can dynamically ask the client for additional information. So it's already in a process of doing something, but it figures out, oh, I need more information from the client. So it can ask back, hey, please provide your contact information in this case. So this is also sent from the server to the client, asking for additional information. And this is also where semantics and where definitions in the model, in the protocol specification come in play. For example, you are not allowed to ask the user for sensitive information. So this is something that you will find in the MCP specification, and that clients and servers need to adhere. Both need to make sure that the server does not request any sensitive information. Yeah. So this is MCP in a nutshell. It's JSON messages going back and forth, and different functionality that the client and the server can offer. And around the protocol, tons of pre-built MCP servers are popping up for lots of different tools, libraries, whatever. And github.com/MCP is a curated set of these MCP servers that you can, I highly recommend browsing them. And these are at the moment they are curated, but GitHub is thinking about providing a community process where you can contribute this stuff. So it's similar to Artifact Hub.io for cloud native artifacts like Helm charts and stuff. In that case, for MCP servers. So probably a lot of the tools that you use in your development process already provide some kind of MCP server. So that's the good news. Through the standardization, you don't have to develop and build all of that stuff yourself, but you need to securely provide it within your organization. And that's the next thing I want to highlight here. For example, mcpazure.com is an example of how you can use Azure API Center to provide an internal marketplace for MCP servers. And combined with the API management, you also can proxy the request to the MCP servers through a central API management, and ensuring that everything is authenticated and secured. So at the end of the day, this is what the developer portal is for the developer. the MCP registry, the MCP marketplace would be for your AI agents. And there is even specification, or they are currently in the process of specifying the MCP registry as part of MCP, which then allows the MCP host to connect to a registry and read all the different servers that are available, and you can easily enable and disable different MCP servers. And for your AI agents, this is then the developer portal with all the tools they can use to do their job. So I highly encourage you, have a look at it. And at some point, larger organizations will need something like this to support their AI agents. Next, we wanted to focus on is the templates. So as I said, a good developer platform also has these golden path templates. So scaffolding for different types of services that already fulfill all the best practice, that have everything in place for being tested, and so on. So it's a convenient way for developers to start a new project. And most coding agents, so that the AI agent, when it starts to work on the code, it needs probably a bit more guidance on how to work with the code, how you in your company are doing things. Usually the developer handbook or there are coding guidelines and stuff that the developers read and have to adhere to, but we need to also tell the AI agents how to work with the code, how to name branches, and so on. And we can do that. Most coding agents or IDEs have already, like, they had proprietary mechanisms for that. So there was the .github/copilot instructions MD, there's the Cloud MD, and with agents MD, there is a common standard emerging. So at least I hope. So GitHub already adapted that. So they are also looking for an agents MD. So we have a common place where we can tell our AI agents how to set up a project, how to code, how to test, what security considerations should be taken. So really a README MD just for the AI agent. Highly encourage you to have a look at that. And as it looks like, this will become the README MD in the long run for the agents. And this can even go a lot further. And a project that has seen a lot of hype in the last few months is SpecKit, which is based on, and it's really hard to explain. So I will try to show you a bit what SpecKit actually does and how it works. At the end of the day, SpecKit is a set of templates and scripts. Everything is based on Markdown. So you have different Markdown files, and what you do is you start specifying. So it follows the spec-driven development approach. Quickly go back to the slides. And spec-driven development is basically, before we did the specification, then the developers took the specification and started coding. But once coding was done, the code was the truth and not the specification anymore. This is how it worked before. With AI, we're trying to turn this around. So the specification is actually in a format and structured in a way that an AI agent can take it and completely implemented from end to end, including tests and everything. So really the code itself is generated. You can throw it away. You can tell a different AI model, hey, re-implement this specification, and you will have a working result. So this is the grand idea, and this is where somehow the development together with AI is moving towards, really specifying in a very fine and detailed way what you want, what's your intent, what's the outcome that you expect, and have everything in a human readable markdown in your repository, and then break everything down into tasks that an LLM can actually implement. So that's the big goal. I'm totally honest, at the moment this is still rough around the edges, but it works surprisingly good. So when you start a new project with SpecKit, what it does is it adds some template files, and if you have a look, for example, these are templates. Here we go. For a specification. So how does a feature specification look like? What rules does it follow? What information is required? How granular it should be, and so on. So this is what SpecKit will provide you. This kind of template for how to write a specification. And once you have the specification is not implementation driven, it's really intent driven. So there is hardly any technology in there. So I'm not telling the specification, hey, I want to implement with Java, with .NET or whatever. This is really focused on your functionality. And based on the specification, SpecKit uses some scripts to steer the LLM and then create a plan for how this specification can be implemented. And this is also a template which guides the LLM how to work and what it needs to do. And here you actually start, okay, I want to implement this using some programming language. I want to use these testing frameworks and so on. And this is everything something that you for your organization can standardize. So how do you want to have specification? What should be in there? What technology options do you want to provide? And if the technologies are used, how should they be used? And you can code this into these templates. And then the SpecKit has some scripts that actually, when you create a new project, where you can say, okay, coding agent, I think the coding agents, you can have predefined prompts. And these are the prompts that you can use to actually tell the LLM, I want to create a new specification. And it knows, my specification template is here. And I should use that to create the specification. And the user inputs the actual information. And what happens is, Copilot, in that case, Copilot agent, will create different files. First, the specification, then it will plan, it will break down the plan into tasks, and then actually design a data model. And all of this is a steered process. That's what SpecKit is about, steering the agent based on these templates. And at the end, from that specification, you can always go in and start. You should always go in and make sure the specification is what you want. It will help you bootstrap everything. It will make assumptions. That's what AIs do. But you still can always go in by hand, modify your specification, enhance your specification, and ask the LLM then to, in a structured way, break down the specification and implement the service. So it's kind of vibe coding, but the goal is to have a good specification so that the agent can then code everything from start to beginning. So it's an iterative process where you don't end up with spaghetti code, but you end up with a nice specification, and worst case scenario, you can throw away your implementation, use a different technology, and let the LLM recode it again. So this is the grand goal of this. It is still early stage, but this is really gives you an impression of where this whole coding with AI agents is going to. There's a very good video that has just been released on how SpecKit actually works. Have a look at it. So to quickly wrap this up, how can we actually now? Where should we start? How can we improve our platform? And one approach that we as PRODYNA take very often is to use the platform engineering maturity model. And the maturity model is you define where you're currently at. So you look at all the capabilities and assess their maturity. And from that, you identify, hey, which capability is really used a lot. Where can I get some real gain if I improve my maturity? And that's the goal, to identify certain parts of your development platform that can benefit from having a higher maturity. And there are always, like, every capability is assessed in 4 levels. And there are different aspects that you should look at each capability. Because of time, I will run through this a bit quicker. Everything is documented in this maturity model. Feel free to have a look at it. So the first aspect you should be looking at is the investment. So how are you investing in staff and funds when building your capabilities? And like the lowest maturity level is, someone built something and others in the company are using it. So there's no real investment here. It's just if this person has free time, they will work on this. The next maturity is really, I'm operationalizing a certain capability. Usually there is a team that manages your Git environment. There is a team that manages your Azure platform or your AWS, your cloud platform. And this is how this model works. So the higher you get, the more effort you will need to put in. The next is the adoption. So why and how do users and AI agents discover and use the internal platform and the capabilities? Is it erratic? Like everyone uses it, maybe, or is it extrinsic? So the boss says you have to use that. To, at the end of the day, teams even contributing back to the platform. Interface. This is now you, this maturity model has been developed before AI agents actually were a thing. So but extending the scope, now this gives a really good framework to reassess your maturity with this new aspect of AI agents in mind. And in the interface maturity, you will probably see that you will need to improve. And the next aspect is operations. So how are the platform and the capabilities planned, prioritized, developed, and maintained? By request, is it centrally tracked? Or is it really a managed service? And last but not least, we always want to know how the platform capabilities, so how the users use our product, how good it is, how they use it, all this feedback and the learning. That's the feedback loop going back into the product and improving the product. And also here we have a very low maturity from, sometimes I ask my users how they like my tool, to really having questionnaires, having quantitative and qualitative measurements, and continuously optimizing. And this really gives you a framework on improving your developer platform. Specifically, when you see a big change coming with AI agents introduced to your development process. So the key takeaways from today is standardization around agentic AI has started. Yeah, so it's not proprietary everywhere. And this really allows a larger, so every organization can really start thinking about how to improve their developer platform and enable it using these standards for agentic AI. You can already start today, even if you're not planning to have autonomous agents in the next couple of months. Still having the platform accessible for AI will also help you in your coding agents within your IDE, for example. And with you definitely need a structured approach to plan how to improve, what to improve, when to improve your development platform. This really helps, and all the companies that already have such a model in place and such a discipline in place are now in a very good place to improve towards agentic AI. If you have any questions, so I will check the chat now quickly. If there are any questions. So as far as I can see, there are no questions. You will receive the recording, as far as I've been told. So you didn't see the, and there are contacts in the slides. So feel free to contact me, and yeah, I wish you could. I hope you learned something, or you can take something from this webinar, and hopefully see you next time. And yeah, have a good rest of your day.